Hello, let me start from where I had left off earlier. The exercise earlier was how to make a small box of a handheld remote, and what triggered the remote exercise is this. You have seen that, no? We do have a burden of remotes everywhere. There are just too many of them, and it's really a difficult issue. And you see, they are just unbelievably complicated. Here we need to find out whether do we really need to have everything. Hence, I had taken you through a large exercise of saying, can we make a small remote control? Okay. Then when we made this remote control, you will notice that was the thing where I had left you last. You remember, this was one of the remote controls, and then I had taken you what you call through a walkthrough, saying how to make a cardboard device simply at home and don't need to go to a professional printer. And contrary to popular belief, home printers still don't do a really good job. Now, I will start this time with a slightly different device. You see here, that is a seminar timer meant for students. The idea being, can we make something such that anybody can make it? And why a seminar timer? Because typically this is what students will be very familiar. Now, if you look at my display, one of the first thing is at the background we have a graph sheet. I thought I will show you the seminar timer and all the things. So, at the back you see a big large group of people who are working here. That is me. This is the industrial designer we have. This is the graphics and user interface designer. Then he is the electronics engineer. Then he is the PCB maker. Then we have the assembly person, and then we have two people who are from the sheet metal shop. This is where I get into saying we probably need to make a simple cardboard rendering, so that before we end up having to get it fabricated, we need to pitch our idea to somebody. When we pitch our idea, if you are just to make a PowerPoint presentation, it does not sell that well. Nobody has the patience to see too many PowerPoints. However, if you have a simpler 3D physical model, people will invariably appreciate your effort and choose one of them. If you go to the another view of this device, you see here, this is the bottom view, and still we have the graph. This is what I have shown you in the front. One of the first things you will notice is, this is meant for a student seminar. In the case of a student seminar, generally total amount of time, number of students I have to talk is fixed. So, typically most of them fall under around 6 people to the hour or 5 people in an hour, which will be 10 to 12 minutes. So, If you look at my display, there is something here which says, of course that was a mistake because somebody played with it, typically around 8 minutes will be there. So, if you see at the back, see this beeps before minutes and then rapid brief, what do you call beeping after that. Now, the thing is how to lay out the front panel. Laying out the front panel is not that easy a job as we think it is. There is still a lot of time involved in it. One of the first issues is, where do you put this mark and what does it mean and what does this mean? Okay. And what is this 0? What is that 0 doing here? That does it mean is it off or does it mean it is on? That is where we need to make something to make sure things work. Now comes to the side profile of it, saying, you see this inclination. Here in this case it seems to be approximately a little less than 30 degrees. So, for a person sitting on the table and looking at it, it makes sense. And other details you would like to notice is probably have seen here, there is a oblong hole here, but while there is a locating hole here. So, this is traditional in any of the mechanical assemblies, saying we need it because we want to ensure that from the pure fit point of view, any base will fit any other cover. Seen that, no? Now from the top, it is a little easy and not so easy also. How should it look? Typically on the table, this is probably how it is going to look. It does not look very elegant, have you noticed this first of all? Because in the beginning, if we had made a prototype, before launching the prototype, we had made a small cardboard enclosure and made things would have been easier. Now have a look at this, which was made earlier. If you look a little closer, you will notice that, let me shift hands. You have the device which sets the period up and down. Then there is just one button which just says start and stop. And most important is, you have seen this red colored thing, that is typically a tally light. You would have seen these tally lights on cameras and everywhere saying recording has started. And right now, of course, several of our new economy, things are edited. But when you are into news gathering, when you are into regular video, what is called a camera chain will be there. Usually a 3 camera chain is normal, and the tally light tells you that the device is on. If we had made it, this is an afterthought, this is done only maybe last few years that was thought. If this was done earlier and presented to the team, then we would have known, saying what type of keys are available, what type of a set switch is there, and avoided some of the things here. So, if you see here, when you see it, the person there outside has no clue whether it is running and what is happening. So, I would have loved if we had a tally light on top of it. And you see this here, the switch, and it says battery, and conventionally should it have been reversed? 0 means generally stop, or is it run? Line means is it is it in and out or anything. These clarifications could have been avoided, and we have a little issue about should it be on top or what does this mean, should it be there. Now you see this typically is development for the sheet metal. After having made the whole device, we would have noticed that not very clean. You see, we wanted a recess here, and the back, there is a small error at the back. I will show you in one of those these things here now. So, how do we you see here at the back now, if you see, while this is a right angle, there is a little some problem here. Whatever we wanted to do now, all the that precision and things have been lost because of the small problem there. Imagine if we had made the model as I have suggested before and presented to the team, things should have been different. Now comes the thing, this is a rendered 3D solid, and the magic is these days there are any number of programs which are available on the internet which are partly free to try or with a limited functionality, and one of them is save is disabled afterwards, or lot of what do you call watermarks are generated saying this is done on a trial package of something and all that. So, using one of those trial these things have been made here, this has not been saved. After it is rendered, the screen capture has been taken and saved, so that I can demonstrate it here. Now, the difference between this and this is, you have seen here everything looks sharp, especially this point. Here there is a small radius. So, this is typically how rendered objects look. There is a small highlight which catches it. Now, we come to the important aspect of how do we fabricate this device. When we want to do the fabrication, we end up with having to split it into several parts and try to make whatever we wanted to try in the first place. Observe this, this could be the front panel we are looking for, just a concept has been made, just keep looking at it and you will be able to see here what does this mean, and then what are all this colored thing, have they been only made such that just for being made, are they made, or do they have a function? So, what does it all do there? Another equally important thing here is, this is probably if we had made this earlier. Now, with using our new Arduino and all this, it is very easy and convenient for us to make a simple cardboard model, and having made the cardboard model, we can now take a call on what should be presented there, and do we need the tally light at all. I will walk you through another model which I thought will make sense. This has been done just 2 days ago, while that timer what I had shown you was very old. Imagine this is just a box, okay, but in this case it is a 3D rendered prismatic object. So, in the 3D rendered prismatic object, first thing you see here is one side there is a digital timer. So, in case the speaker is more familiar with this, maybe we can present this to the speaker. Other side we have a clock. Generally, resetting these clocks every time like this thing is very complicated and difficult. Compared to that, it is very easy to set this as a timer and all that, and imagine at the base you have a Arduino PCB It is very easy for us to control this. So, this can probably face the speaker, and then you see what look on top now, a little like the police lights we see there. In this they are just patches. I will call this a patch of blue, and then we have the two alarming things. The concept here being, once you start that orange device stays lighted up. So, that has the function of a tally light, saying now the speaker is on, and then this red is finally eventually to stop. It looks smart to me, but I am sure others may not think it is as smart. This faces the chair, the person who is conducting the seminar. How do we do it? If possible, probably we can attach a real analog clock, or these days if you have a display can do it, but I would prefer to make it, and you see here the same things are visible on both sides. Now comes to the how do we make these things? See here, very cute and interesting thing. This is the development drawing. Development drawing, in this case you have base, side flaps, then you have the actual support thing, and this is the top which goes over, and these are tabs that hold the top and bottom together, and whatever this rendering I showed you, it looks very reasonably real. It is nothing, it is just something that has been just made in the workshop, and in fact this is not even a 3D, it is just a graphic that is stuck on top of it, but you see how real it looks like. Now if we were to present it to your group like that, I told you, even that small unit had 8 people, because we had made around 200 of those units and allowed whoever wanted to take one back. So, now I come to the importance of, all you need to do is take it and print it. Once you print it, you need not worry, it is there at home. Easiest things to do is this simple printout. Remember last time I had taken you through all this, all we need to do is just stick it on a piece of paper, and we have the thing what we are looking for. I think I showed you this just to say you just need to proceed like this, and eventually what looks not a very big deal for us to go about and assembling a beautiful model which I have shown. Beauty being, now this can be taken wherever you want to go, and you can just demonstrate it. Coming back to that cardboard model which I have made, this is something which can be taken off the internet easily. If you go and look for the device which you are likely to see anytime, all you have to do is just search for it, and usually in the application sheet a 1:1 drawing or a picture is given, or in case you already have the device, just take a photograph, and same thing here. I had just gone to the internet, in fact I have taken this from one of the clock catalogs. So, I have a beautiful clock face here. Now, if we print it at one of the developmental drawings which I shown you, this represents a top, this represents the face that is facing the speaker, this represents the chair. If you just print it now, there is a photorealistic photo print that has been taken from the computer and probably at your work spot. No need to talk to anybody or anything. Once you have this, now it is a question of, you see here tabs have been given here. This is some texture that has been given to make it look like it is either a plastic or a graph. This is absolute base in which things are sitting, and these are what do you say, sides. These are tabs which will help hold this thing. This goes here, this goes here, this goes on this side, and this goes here. With this we are ready. Oh, I am sorry, you need to tilt it like this, it comes like this. So, this little curve is there, this curve comes here. And to make modeling is easy, we can probably take a styrofoam piece, a prismatic styrofoam piece of this much, keep it in the center, fold everything and stick the top portion to this here. Once we have done this, and you can have 2 or 3 versions of it. As I said earlier, no, one of them has a digital display here, a normal clock display on the other side. Alternately, you can have digital on both sides, and only for convenience sake, I have just shown this as a small 1/4 of a circle. Nothing prevents us to make it like a nice police light. That is, you can have a oblate spheroid, that is what I call take an ellipse and then extrude it, and it looks absolutely like a police light. Why it is? That is the small pun which we are playing in, saying you are being chased by time. I think I am smart, but probably it does not go well, but the thing is at least that the person there will know about it, and inside it is very easy for us to put all the electronics and then probably put a small LED or something which is coming here, and the top full portion on top now can probably be a transparent window with white LEDs all along, and then this window will make sure things are, otherwise you can have a red LED, yellow LED, and then depending on whether you like green or blue, put those LEDs. See here, once you print this, converting it into a real product is extremely easy, which I was trying to say right from the beginning. So now if you go through here, we have we can probably avoid this. It shows as a burden, and the gag is actually, we have too many of them. Do we need this, which also has what you call something to go up and down, and there are keys which are shown here, and this front, this thing also is need there, and then due to lug around so many remotes in your place, just one remote is sufficient. So it is with this timer which I was talking to you about. You can probably, it is much easier for you just to probably just make one timer and then happily survive. So in this, the whole focus once again is saying how to conceive of a simple product. In this case, I have shown you what could have been a very simple product, and eventually converted it into a sheet metal. And if you see, most products we know invariably have flat faces. Minimum is probably, you can make a triangular tetrahedron with only 4 faces, otherwise you end up with typically a parallelepiped thing which has around 6 faces. Now in these 6 faces, having made this, you can take a call on either to make this whole front base as one and sides and top as one. The advantage being, if you take it out, remaining everything is there, things are mounted here already, they are available. and in this case we have not actually tried, which I have kept on showing earlier. It is even probably possible to mount a battery holder and a cover here. You can open the cover and put the batteries inside. In case it looks a little tricky, it is probably much easier to have a tube like thing, and you push the batteries inside and snap the cover which joins the first source cell, take it out. All this can be done via 3D modeling on your software, that is solid modeling. Then take a printout of all these features directly from the internet, and then you can directly show this. And if you are smart enough, you can probably also use it for making all the electronics inside. I will see whether I can locate it again one more time on my in my collection of photographs. My favorite is this. This is the kitchen timer which are likely to find at home. So, if you are to have an Arduino, and then if you have the display and all that, you can always make these things such that eventually it will be extremely easy for you to make these things as you like at home. All the details are available on the internet, and I think I showed you earlier. As much detail as possible you can pick out from there, and once you complete your model based on the dimensions that are given here, total saying this is around 42 millimeter by 67 millimeters, and then this is the display. So, probably the triangular face I have shown you can be part of this display on one side, other side you do not need it, you just need to stick things, and in due course you have actually nice working devices. And once you decide all this, probably in this case I have just taken that I think it is a Mentos box and try to make something about it, but this is not the right way of making it. For you to understand the first time, probably this is the easiest way of you to make these things. Having done this, it is a matter of ease for you to go about making anything you want very easily. Remember this? See this corner. This is where I thought I will stress an important thing. This is ideally to be done by assembling using probably polycarbonate or acrylic sheets, and printing an inclined surface like this usually does not come out well in most 3D printers on two counts. First of all, if you see the cross section, whichever way you orient it, we end up with a lot of support material being wasted and granularity on the front surface. So, you will end up having to fix one more sticker or fascia plate on top of it. So, the moment you go to all these things, most of these things can be successfully avoided if you can make a simple what you call rendering on your own. You have seen that, no? This does not have any thickness, 0 thickness, but what goes inside where and all that can easily be decided on it. So, I will stop here, and this is just a what you call how to make a development sheet and all that. Next time we will go on to our workshop where you can see first of all very fundamental things, saying how do we make these parts, how do you bend them and so on. Second thing is how do you make a layout. This is where what I feel is a considerable amount of accuracy can be done without having to resort to skill, what do you call, improvement of your skill. If you are an electronics engineer, you should concentrate on your electronics. If you are a mechanical engineer, you should concentrate on those things, and once you pass it on or for you to try to the next what do you call the fabrication, they are the experts in that. There are tool engineers, there are what do you call forming engineers, there are people experts in all the operations. Once you give it to them, they know probably how to make this layout of a sheet, how to carry on the bending, what is a practical thing, and how do you get 100% yield of those things. If you get into those details, it is a problem, but first time you make your what I call concept very well and present it to them. From there, for them taking it is very easy. They may give you suggestions about it. For you to make it first time, instead of you are trying to upgrade your skill and spending wasting material, if you are to make a printout of a developed drawing like this, including in between the gaps they represent there is a small gap there, can you see? This gap represents the internal bending elements. So, if you add all these things and make a scale drawing, you just can happily transfer this to the sheet metal what you have. And in case you have plastic or any other non-metallic items, you can take these small pieces individually and take the most important what goes in. This can, for example, sit outside or this can go inside. And once again, based on that, if you extract these the what they call the various faces and then present it to the fabricator or somebody, it is easy, very easy for them to first of all estimate the total material that is required. You understand? No, most important is how much material that is required, or the scale of operation. Up to maybe 100 or 200 you can manage it, but then if you want to make tens of thousands of it, finally all the cost comes down to what is the incremental cost of the material. And can you reduce the thickness, then new operation has come, or how do you now fabricate it in several other places, which is easier. So, thank you. Next session, if possible, I will try to concentrate on the workshop items, and while workshop skill has been there, and while making drawing and somebody understanding the drawing, my next jump is going to be saying you take a printout, a scaled printout, somehow transfer it to a sheet and then directly use it without having to do what I call vernier height gauge marking, and then most likely you will have a very useful first cut prototype, is very easy to make. So, thank you. We will meet again. Thank you.